let's consider relative motion. I'm not talking about your auntie or your uncle. I'm talking about motion of things that have velocity relative to other things. So here we have a person, and this person is walking on board a train, while the train is moving to the right. So we can say that our velocity of the train with respect to the Earth is 10 meters per second. Our velocity of our person with respect to the train, VPT, is going to be in the negative direction, and it'll be this negative 2 meters per second. And then our velocity of our person with respect to the Earth, just knowing these two things, I can tell you what this velocity is. If our train's moving to the right and we're moving to the left on the train, then the difference between these two will give me the net velocity. And by the difference, I mean the vector sum. So you add up this vector and this vector. This is positive to the right. This is negative to the right, or positive to the left. So positive 10 plus a negative 2 gives us a positive 8. So our velocity of a person with respect to the Earth is going to be 8 meters per second. And written as a vector expression, this says that the velocity of our person with respect to the Earth is equal to the velocity of our person with respect to the train plus the velocity of the train with respect to the Earth. All right, we used a very concrete example here because the abstract way is kind of tough for people to get their minds around sometimes. And here you can look at these subscripts, person with respect to the train, train with respect to the Earth. You can kind of look at this and see that because we have the train is on the second position here and on the first position here. So combining these, we kind of eliminate them and we end up with the velocity of the person with respect to the Earth, right? So person to the train, train to the Earth, get rid of those in the middle, and you get person with respect to the Earth. I'll point out that since this vector addition is commutative, we can do it either way first. You could have written this the other way as well and had the trains at the beginning and the end. Like, it's not necessarily that they're on the inside. The point is that it's on the first position for one and on the second position for the other. And so then that would relate the person to the Earth, right? The first position and the second position stay as you combine those. More generally, if you want to extend this to multiple things, you could say that velocity of something with respect to some other thing. Well, if I have a relative velocity of A to B and a relative velocity of B to C and a relative velocity of C to D, then the velocity of A with respect to D is just the sum of all of those other things as a vector sum. So that's relative motion. That's one-dimensional. If you want it in 2 dimensions or 3 dimensions, here you go. We have X, Y, and Z here, and we have some reference frame S, and then we have some other reference frame S prime. So if you consider some point P, you can define that point P in terms of the original reference frame S as this position of P with respect to this reference frame S, so RPS. Or you could define it in terms of this other reference frame S prime as RPS prime. So this is the vector that defines this in this other coordinate system. So if I want to relate those, as long as I know the position of this S prime coordinate system with respect to that original S coordinate system, I have the relative position of S prime with respect to S, so the position of S prime with respect to S, then I can relate these and say that my position of P with respect to S is going to equal my position of P with respect to S prime plus my position of S prime with respect to S. And you can kind of see that vector-wise, add up these two vectors, and you end up with this resulting vector. The velocities hold as well. When you take the derivative with respect to time, you can then say that the velocity of P with respect to S is equal to the velocity of P with respect to S prime plus the velocity of S prime with respect to S, and similarly for acceleration, the same way.